In this first session of the series, we will focus on how institutions approach the problem, with presentations by industry experts on the UN Sustainable Development Goals, the RIBA Sustainable Outcome Guides, and a road to net zero as proposed by ARAP. This will be followed by This will be followed by a panel and audience discussion to develop the ideas on how we as architects and designers can approach these critical issues, the challenges and opportunities posed by this climate emergency, and the net zero concept as a response. I'm Sandra Woodall and will be hosting the session today. I've lived and worked as an architect and an urbanist here for 25 years in the group GCC. I am a fellow of the RIBA and an academician at the UK's Academy of Urbanism. For the majority of my time here in the Gulf, I have had the pleasure of being the design director at Tangram Gulf, the multidisciplinary regional arm of UK's Tangram Architects and Designers Limited. We are one of the RIBA's inaugural international chartered practices and have studios and projects all across GCC and North Africa. As an organisation, we have delivered projects in the region for over 30 years, whilst witnessing and being involved from the outset in a number of regionally significant projects and programmes that have propelled the green building trajectory forwards across the GCC. As we wait for everyone to join us today, I'll just run through some of the key regional programmes that we've been involved in the last couple of decades. In 2004, in Dubai, we commenced the design and delivery of a series of what was to become 11 community-based social infrastructure projects delivered over 7 years for the government of Dubai, incorporating passive sustainable design principles and developed contextually contemporary solutions that respond to climatic design. We delivered the government's first ever green roof building in 2007. And from the solutions offered in this first phase of government projects, the government formulated its Sustainable Design Standard Codes in 2010, mandating the use for all new government buildings to be built from 2011. And by 2014, when 44 of such buildings have been realised, a quarter of which have been delivered by Tangram, these codes were applicable to all new buildings across the Emirate. In 2016, this was expanded into Dubai's very own contextually responsive sustainable design rating system, the Al-Safat. Developed to create a unified set of construction standards to promote sustainable development and innovation in building design, ratified and mandated for use by all just last October 2020, in readiness to support the ideals and realisation of Dubai's 2040 Urban Development Plan, which was launched only a couple of days ago. From our Doha studio in Qatar, we have undertaken research and development of traditional regional cooling systems and desert urbanisation and how these could be interpreted at district cooling levels. Our findings here were presented at 2014 World Stadium Design Congress, informing the research and many refrigerant-free proposals that have been developed and included in many of the designs for the refurbished and new stadia built in preparation for next year's FIFA World Cup tournament in Qatar. And in Abu Dhabi, we joined the UAE's Civil Nuclear Energy Programme to provide a new source of clean nuclear energy, targeting to fulfill 25% of the UAE nation's future energy supply. The first such programme in the Arab world. We were brought in initially with our background and strengths to design a mission timeline critical radiochemistry laboratory as part of the emergency response campus that we developed in the Western region, which would support the main Al Baraka power plant. This RAD lab, an environmental radiological testing facility, was not only mission critical with regards to the commencement of the very first nuclear fuel burning cycle, but due to the nature of tests to be undertaken within it, Material choices available for consideration in the construction of the scheme. A steel-framed glass box was the only solution to not distort the measurements to be undertaken and benchmarked within the laboratory. So in the middle of the Western Desert with a client whose very ethos and entire reason for being was that of sustainability. We knew we would need to use passive and active strategies and draw on green and blue technologies to deliver what was to become the most advanced facility of its kind to the timescale required, and that allowed the first ever fuel burning cycle to commence on time. Reactor 1 of the power plant was ultimately connected to the national grid on August the 1st of last summer, commencing a new era for clean energy production in the region. Wider in the Gulf, over the last generation or so, the sustainable trajectory emulated that of the UAE. The GCC regional first in Kuwait in 1984 saw the incorporation of photovoltaic cells on the roof of the newly built English school in Salwa. And around this point, global concern for damage that we as a species were inflicting on our natural environment started to grow apace. United Nations Development Summits, international agreements, and in our industry, the formation of green building councils, sustainable building regulatory standards and rating systems have followed, and which we have now reached double figures of in the types and use across the 6 nations of the GCC alone. And constantly evolving national plans to reach ambitious decarbonisation targets and urban development plans ensue. So where are we now? Across the region, we are seeing the fruition of this sustainability trajectory. And the concept of net zero is now taking shape. Sustainability is now at the core of much of the projects that the construction industry is showcasing on the world stage. We are seeing the construction of the world's largest solar energy centres. Abu Dhabi is producing energy at the cheapest rates per kilowatt hour than any other energy type in history. Here in Dubai, Grimshaw's Terra Pavilion has launched its soft opening to visitors in advance of the delayed start of Dubai Expos 2020. This sustainability pavilion targets a net zero energy status and looks to achieve net zero water status. The project is targeting LEED Platinum certification, along with all Expo KPIs and the Al Safat green building regulations of Dubai. In Qatar, we will see the greenest ever FIFA World Cup Finals tournament in history next year. And in Kuwait, since leading the way in the Middle East's first photovoltaic integration in buildings in 1984, we have witnessed schemes seeking and achieving LEED or GSAS certifications. The new campus of Kuwait University will seek to acquire LEED certification. And here, as the picture shows, Foster's new Kuwait Airport Terminal 2 targets LEED Gold certification. Bahrain, wind turbines were introduced to this region with Atkins World Trade Center development completed around a decade ago. The towers were designed so that they will funnel the onshore wind between them while simultaneously creating a negative pressure behind in order to accelerate the wind velocity, creating even more energy. The turbines were designed to supply up to 15% of the tower's total electrical consumption. And in Oman, the Oman Convention and Exhibition Centre, part of Omran's master-planned Allies and Morrison's Madinat Al Irfan development, is the first tourism development in the country to achieve a LEED Gold certification from the US Green Building Council. For package 2, which is here, the Exhibition Centre, Car Park, and the Energy Centre. And last but not least, in Saudi Arabia, the newly launched NEOM development has recently exhibited its vision for a car-free city utilizing advanced technologies and embracing zero carbon solutions. The line, a new smart city, is probably taking us definitely now into the realms of giga projects. As the world is now setting its sights on a net zero solutions, moving beyond decarbonisation, low carbon, carbon neutral, and zero energy targets, etc., etc., etc. And as the timelines for targeted deadlines for the delivery of these grow ever closer, within the GCC and of course the wider Middle East and beyond, it brings us a new concept that we need to better understand and equip ourselves with the skills and tools to offer better informed solutions in the built environment. So to better introduce us to us all of what net zero means to the future of the construction industry, we have invited our expert panelists here today to bring us global as well as regional and GCC specific insights. Please feel free to contribute your thoughts throughout the session using the chat box. Do let us know who you are and where you're based. We hope to offer you the chance to put any questions that you may have direct to the panelists at the end of the presentations today, when we will invite all of those who wish to join us on camera and contribute and engage direct. So with a very warm welcome, we are delighted to have joining us here today, the first presentation, Mina Asman, Associate Director and Sustainability Lead for Skidmore, Owens and Merrill. Mina leads the sustainability and well-being daily operations and long-term vision for achieving excellence in practice. She has experience in a wide variety of projects in the UK, Europe, the Middle East and Asia, bringing us a greater understanding of the implications for sustainable design in different climatic, social and regulatory contexts. Today, Mina will offer us an overview of the UN Sustainable Development Goals together with other related international agreements and describe their importance for built environment professionals, identifying regional and GCC projects that demonstrate how each of these goals can be achieved. So thank you very much for offering your time and expertise to us here today, Mina. Please, when you are ready, do begin.
Thank you very much, dear Sandra, for that kind introduction. I wanted to share my screen and also make sure that you can all hear me well and hopefully see my screen as well. Perfect, you can see on my screen, right? So thank you so much for inviting me to be a part of this exciting event. In this presentation, I would like to talk about the United Nations Sustainable Development Goals for 2030 and how these goals can be applied from principles to practice. Hopefully you can see my screen still. Perfect. So the aim of the presentation is to inform you on the global climate change context as it relates to the built environment and people, to give you an overview of the international commitments that aims to address climate change, and also to provide you with a detailed understanding of the United Nations Sustainable Development Goals with key examples demonstrating how these can manifest themselves within the built environments we create. But let me first start by setting the context. And in this crucial decade for climate action, we cannot simply advocate for a resilient future unless we're demonstrating the change we want to see ourselves within the built environment sector. The next 10 years, which the United Nations calls as Decade of Action, are possibly the most critical 10 years of our time, where we need to embolden our collective action to halt climate change and mitigate its impacts. United Nations Sustainable Development Goals for 2030 provides a framework within which we can holistically address the multitude of challenges we're all globally facing today and will do so in the future. Climate change is already showing clear signs with the unfortunate storms, floods, heat waves, and wildfires, among others, currently risking the livelihoods of 4,000 people only in the Arabian Peninsula. And it is also anticipated that these conditions will continue to exacerbate as our population increases. The expected reach to 2.4 billion people within the next 30 years is already demanding intense densification of our existing cities today. And it is anticipated that within the next 35 years, over 230 billion square meters of buildings will be renovated and or constructed in cities worldwide. So if drastic measures are not taken, this growth will significantly contribute to global warming, beyond the built environment's current 40% annual contribution to the greenhouse gas emissions. We also recognize that although growing cities can bring benefits, but to failure to manage that rapid urbanization well will also bring in significant profounds of instability with increased poverty, inequity, and vulnerability in societies all around the world. And as our cities continue to densify, health risks will also continue to become a growing concern, as we currently experience with the unfortunate global pandemic. So our responsibility in the fight against climate change goes beyond just minimizing our negative impact on the planet, and it really embraces safeguarding our own health for the future. Over the last 10 years, we have seen an upsurge in the data and scientific evidence collated by many international organizations on the global climate change context, as well as guidance delivered by these organizations outlining key ambitions to be met at specific milestones. These leading international organizations that have become the main source of knowledge include United Nations, World Green Building Council, and the Global Alliance for Buildings and Construction, among others. And as the voices of the International Committee, these organizations have formulated a range of agreements as well as reports to present the state of the art, to offer insights to emerging trends, and also to share guidance on how to tackle the unprecedented existential challenges the humanity faces. Some of the most notable of such agreements and documents are presented here. Among these, we will today focus on the United Nations 2030 Agenda for Sustainable Development. The agenda is a plan of action for people, planet, and prosperity. It is accepted by all countries and is acceptable to all, taking into account different national realities, capacities, and levels of development, as well as national policies and priorities. And at the heart of the 2030 Agenda lies the 17 Sustainable Development Goals, defined as an urgent call for action to all countries to unite in a global partnership. Although it may not be immediately apparent at first, all the 17 goals can be directly and or indirectly impacted by the choices and decisions we take within the built environment sector. So let's see how the principles of the 17 goals have in the recent years been translated to practice in various examples around the world. The first United Nations Sustainable Development Goals for 2030 looks at ending poverty in all its forms and dimensions. And it acknowledges that the built environment can play a critical role in contributing to this mission. Voluntary Home for Homeless Children by Ray Meeker and Anupama Kundu is an inspirational build project which delivers on this goal's mission. Located in Pondicherry, India, this mud house is a proof of how innovative and creative thinking, very much underpinned by vernacular solutions, can provide a decent and affordable housing that is well made with local craftsmanship and materials. It is truly an inspirational project. And as its name speaks for itself, the mission of the second UN SDG is to end all forms of hunger and malnutrition all around the world. It therefore encourages projects that can help with the transition to sustainable food production and agriculture. Dubai's Sustainable City is an exemplar of such a project, where a 3-hectare farm grows herbs, fruits, and vegetables for the wider local community, not only providing a sustainable and healthy food source, but also bringing the local community together to collectively contribute to this important mission. The third goal is good health and well-being. This goal's mission is to ensure healthy lives, addressing inequalities and promoting well-being for all at all ages. Very much aligned with this goal's mission, the Aga Khan Award winner Superkilen Park in Copenhagen, designed by Bjarke Ingels Architects, presents a hybrid fitness park, which provides everyone inclusive and safe access to spaces that encourage them to be healthy and active. It achieves this by optimizing urban space into a public amenity which is especially needed in our growing cities where urban public spaces continue to become scarce and compete for multiple functions. The next goal is about ensuring inclusive, equitable, and lifelong quality education for all. The Zatari classroom in the Zatari Village's community dome in Jordan is a small-scale example of how the quality education goals mission manifests itself in the design of a built environment. Inspired by vernacular beehive houses of Syria and built by local workers out of adobe, this small building offers a learning space for the Syrian refugee children. And equally important, it actually increases the livelihoods of the local community by training them on low-cost, energy-efficient, and adaptable buildings for a reconstruction of their village. The fifth United Nations goal very much encourages built environment designs that advance gender equality and empower women as well as young girls. Located in eastern rural Uganda, Kachumbala Maternity Unit by HSK Architects demonstrates how a built environment caters to priorities of an impoverished region with limited access to healthcare, where high maternity deaths sadly threaten the lives of many women and young girls on a daily basis. Clean water and sanitation goal aims to safeguard clean water and ensure that it is available to all and that is sustainably managed. The concave double roof system, designed by BM Design Studios, aims to contribute to clean water availability by capturing as much rainwater as possible, especially in arid climates where climate is quite dry and where lack of water will likely lead to mass displacement in the future. The next goal is all about having access to affordable, reliable, and sustainable energy sources. By providing electricity generated with nuclear energy, as presented by Sandra earlier, Baraka Nuclear Power Plant in Abu Dhabi renders the UAE officially the first country in the Arab world to become a peaceful nuclear energy generating and operating nation. The eighth goal, the Eastern Work and Economic Growth mission, is to promote sustained, inclusive, and sustainable growth for all. The rehabilitation of the historic Bazaar of Tabriz in Iran, undertaken by ICTO East Azerbaijan office, is a unique case study that delivers on the mission of this goal by promoting Iran's craft industries and securing a future for local trades for decades to come. This beautiful building is also recognized as a World Heritage Site and has won the International Aga Khan Award for Architecture in 2013. It is truly an inspirational project. The next Sustainable Development Goal encourages the advancement of sustainable industrialization and innovation, especially in those places around the world that do not have access to modern industry. Madinat Al Arfan Master Plan takes the mission of catalyzing change through innovative thinking to a much bigger scale. Designed by Arab in collaboration with allies and Morrison, the master plan is a vision of a 40-year-old plan of a low-carbon city district in Muscat, Oman. And as its name stands, the next goal's mission is to reduce inequalities within and among countries all around the world. With the ambition to create the most accessible office building in the world, the Disabled People's Organization in Denmark has built a headquarters in Taustrup. Designed by Huba Architecture, this building sheds light on the need of universal design, and it demonstrates how with an integrated, accessible design approach, a building can create a work environment which is equal for all, regardless of their disabilities. Following on, the 11th goal of sustainable cities and communities is probably the main goal that all built environment professionals can see direct links to in the work they deliver on a day-to-day basis. This particular goal's mission is to make cities and human settlements inclusive, safe, resilient, as well as sustainable. We see a great example of a built project in Cape Town that delivers on this goal's mission. A housing project by urban think tank called Empower Shack brings safe and low-cost housing to residents of South Africa's informal settlements. Another very built environment sector related goal is the 12th goal of responsible consumption and production. This goal's mission is to ensure sustainable consumption and production patterns by encouraging building designs that minimize material use, waste, and also transform building construction into becoming an essential part of the creative thought process in the design of a building. The Abwab Pavilion, designed by Fahed and architects for the Dubai Design Week a few years ago, is an exemplary project that delivers on the mission of this goal. Constructed using old mattress wires that were discarded as waste, this pavilion embraces a circular design and delivery approach where materials that are discarded are given a second life and a new purpose, consequently diverting a significant amount of material waste from landfill. Climate Action Goal demands urgent action to combat climate change and mitigate its impacts all around the world. Located in Saudi Arabia near Riyadh, the Wadi Hanifa is an exemplar that demonstrates how climate action can be delivered by restoring nature, in this case a natural water drainage course, which provides additional water resources for the rural and urban inhabitants of the region, while also offering them a recreational area to enjoy throughout the year. The 14th United Nations 2030 goal focuses on life below water, and it aims to conserve and protect oceans, seas, and marine resources all around the world. The Wadden Sea Center by Dorte Mandrup Architects is a unique project in Denmark that evidences how designing a building in harmony with its surrounding context can create awareness and understanding of that building's specific environment, in this case, the surrounding marshlands and the sea. And on the other spectrum, the next goal focuses on life on land and missions to protect, restore, and promote sustainable use of terrestrial ecosystems, as well as sustainably manage forests and reverse land degradation. By raising awareness on eco-habitats, the Jubail Mangrove Park in Abu Dhabi demonstrates how a park's integrated design can provide a balance of minimal man-made intervention and preservation of natural environment, while also enabling human interaction with vulnerable species found in nature. This park has been identified as the first self-contained education, nature, and leisure destination of its kind in the Emirate of Abu Dhabi. The 16th United Nations 2030 Goals mission is to promote peaceful and inclusive societies for sustainable development, to provide access to justice for all, and to build effective, accountable, and inclusive institutions at all levels. The vibrant community center in Manica, Mozambique delivers on this goals mission by optimizing local building techniques that use regional materials to modernize the construction processes in the area without a rupture in the know-how of populations. By sitting in harmony with its local context and enabling the local community to thrive in unison, this building also has become a part of the area's cultural landscape and local identity. The last United Nations Sustainable Development Goal focuses on strengthening global partnerships for sustainable development. Designed by Grimshaw Architects and as presented by Sandra earlier, the Sustainability Pavilion at the Dubai Expo demonstrates how cross-disciplinary partnership and collaboration between architects, engineers, technical researchers, and even scientists from NASA can deliver both net zero energy and water building, inspiring current and future generations to place sustainability at the heart of their actions. United Nations Sustainable Development Goals for 2030 are truly a powerful tool to create change. We must therefore collectively embrace their principles and continuously carry them to our practice. Now I would like to end my presentation by playing an inspirational video on the United Nations by the United Nations Secretary.
The Sustainable Development Goals are the world's action plan for a fair globalization and a better future for all. We have 10 years to bring that vision to life, and we can only get there together. That is why we have launched a decade of action to deliver the goals, to overcome poverty and inequality, to combat the climate crisis and advance gender equality, to build peaceful, just and inclusive societies free of discrimination and hate in harmony with nature. Join us, step up, seize the moment, and let us work together to meet the goals, move our world forward, and leave no one behind.
Thank you very much.
Thank you, Mina, for your very valuable insights and demonstrating very clearly how each and every one of those United Nations Sustainable Development Goals will be requiring built environment solutions to achieve them all. Thank you. And now we will hand over to Gary Clark. Gary is a Principal Regional Lead Europe, Middle East and Africa for Science and Technology at HOK's London studio. He is the chair of the RIBA Sustainability Futures Group, and he's passionate about bridging the boundaries between academic research, teaching, and practice across many sectors, with sustainability at the core of his architectural philosophy. Gary's expertise today will provide us with a practical explanation of the outcomes that need to be delivered if we are to achieve development which is sustainable. It will translate the United Nations Sustainable Development Goals into meaningful and measurable sustainability outcomes and demonstrate these with two of HOK's local developments. Thank you very much for joining us today, Gary, and for sharing your expertise with us. It's really very much appreciated. Please, when you're ready, do begin.
Great, thanks very much, Sandra, and hello everyone. And yeah, I've got a hard act to follow from Mina there. I'll try my best. So I'll just share my screen. So, okay, thanks. Okay, so you're going to see a little bit of the previous slide, but first thing to say really is, as Mina set out, we're emitting far too much carbon emissions, 37 billion tons in 2018, a third of that in the world, and the Earth at its most absorbs half that amount, and that is debatable as well. At the same time, we're cutting the forest deforestation down the size of the UK every year, and this is a mark of Amazon here, and I think that's our world's lungs that are being destroyed. And at the same time, we're actually going to deep forest, and we're picking up sort of things in terms of viruses, as we know that we shouldn't really try and avoid. The result of that, obviously, we've got some big global problems going on just now. This is the latest one from Johns Hopkins University, 2.5 million dead last week, and rising rapidly. And it's these big global problems require big global solutions, and the same urgency of the COVID response really we need from climate change as well. Now we've got a future ahead of us, and as we're saying, it's a decade of action. If we don't do anything, then the future is going to be on our right hand of the screen here, which is a +4 degrees temperature change. And if we try and get it down to reducing it by 2050, then obviously we're down to about 2 degrees centigrade. At the RIBA, we've been working on several guides for a few years now. So this is the ones I'm going to go through today. So it's the RIBA Sustainable Outcomes Guide, the 2030 Challenge, and the Plan of Work Overview. So all that's going to sort of highlight it into that. And there's a new guide that's going to get published next week, which is the new RIBA Plan for Use. So I'll touch on that during the talk. All the guides are linked back to the UN Sustainable Development Goals, all 17. But what we've done is we've tried to say, behind this 17, there's actually about 300 metrics that you've really got to look at in great depth. So we took the view of saying, okay, how do we manage this, and how do we create a set of metrics that we can manage on a busy project in terms of a small time scale, but obviously trying to keep the spirit of the UN Sustainable Development Goals that Mina went through. So what we've done is we've distilled those down into taking 10 of the UN SDGs, which are linked to more environmental sustainability. Now the RIBA is actually just finishing another set of metrics based on the ethical side of sustainability, and that's going to get published this year as well. But picking up the environmental side, so these are the 10. And then what we've done is we distilled those down into 8 sustainable outcomes. And we can see here, we've combined, for instance, the life life below water and clean water and sanitation into something called sustainable water cycle. So what I'm going to do is I'm just going to touch on each of those briefly, and then we'll wrap up with a few case studies towards the end. So the first one is net zero operational carbon. This is the one that obviously everybody is aware of. And the main thing here is obviously there's no shortage of energy hitting the planet. So the sun is 1 kilowatt per square meter. The problem is, how do we capture it and how do we store it? And that's very much part of that kind of part of our aim in terms of architecture. So the first thing is, and you'll see this quite a lot, is we can't solve the problem by building new buildings. Okay, so this is really one of the things we've got to make do and make the best use of what we've got now. But obviously, in terms of some countries obviously need new buildings, and obviously that's absolutely fine where there's a need. And so if there is a new building, then we've got to think about how we design that. So first thing is, it's fabric first approach. It's we think that almost up to about 50% of that kind of saving of carbon emissions is down to how we design the buildings in the first place. And that's an architectural imperative. Next thing is how we then integrate engineering in terms of regenerative engineering, that's thermal recovery and so forth. Then we look at on-site renewables, and then finally we think about off-site renewables. Now it's important to try and maximize the on-site renewables in the first instance, but really trying to say, well, you can actually offset at a certain point. Then looking at net zero embodied carbon, so this is actually obviously hidden for less. And the key thing there is obviously retrofit first if you can, but then it's employing the circular economy principles that Mina touched on. And this is actually local, low embodied materials, healthy and ethical materials, and carrying out whole life carbon analysis of where you get your materials and how long they're going to last for in terms of this robust and suitable materials for the climate. You can see some wood catchers here. Now looking at sustainable water cycle, and it's in potable litres per person per year. And what we try and do here is obviously minimize the amount of water we use with low flow fittings and leak detection. But really is, as Mina sort of touched on there, is it's capturing as much rainwater as we can, and then that smooths out the kind of seasonal cycles. And that's actually throughout the world. That really is one of the kind of key aspects of this. Sustainable connectivity and transport, obviously part of the one of the benefits of actually this lockdown is that we're doing a lot more online, remote working. And so therefore the travel, we've got to really think about commuting and traveling to work every day. And so really a blended remote working plan for the future is really part of that whole thing. Proximity to public transport is key in terms of what we design, and obviously creating high quality pedestrian links, and then end of journey cycle vision. And this cyclist obviously is kind of geared up for the future. And this is all before we think about electric vehicle infrastructure. Next one is looking at sustainable land use and ecology. And we hear the main thing which the RIBA is trying to do here is actually to say you've got to leave the site with a better ecology than you find it. And we're really sort of targeting a 20% net gain in biodiversity. And we do this obviously picking sites that have been previously developed, retrofitted, or actually brownfield sites. And then we increase that green cover, which actually has amazing benefits in terms of the heat island effect, as well as increasing biodiversity. And we can see the opportunity of productive food landscapes within our urban realm. Next one is good health and well-being, which again is very much aligned with the UN Sustainable Development Goals. But the key strategies here, I think it really is down to this contact side and actually plants in terms of biophilia. We've got to think about good density, we've got to think about indoor air quality, and that's actually right at the top of the agenda, obviously now with COVID. Think about good daylighting as well, and then adaptive thermal comfort and acoustics, and obviously inclusivity as well. Then we move on to something a bit is more and beyond the buildings. This is actually, we've got to recognize that we're creating communities and social value. And so we've got to think about this kind of mixed use in this tenure, creating a piece of city, a bit of an urban realm, creating identity and territory, places that are secure, a bit social. Then we've got permeability through those. And then really this kind of high quality pedestrian links is absolutely key to creating this social value. And the final one is sustainable life cycle cost. Now, this is where we've got to look at the whole life benefits of sustainability. It may cost a little bit more in terms of capital cost, and rough figures are around about 5% for, perhaps a LEED Platinum or a BREEAM Outstanding scheme. But really what we're looking at here is whole life cycle analysis. So it's looking at the energy cost, the material cost, and the operational cost, and we balance that with the added value of our health and well-being that we're creating, and obviously the social value to the local community. And that's how all the kind of the the sustainable outcomes going to come together. And what we do is we've integrated this into the plan of work. So in terms of the 2020 version, so we say we start off with your outcomes at the beginning, and really what we're saying is agree those together with your client. And if you're a client, then really use this as a kind of starting point for thinking about of the outcome. And then it's really flipping it round. It really is designing with the outcome in mind, rather than just actually sort of what type of building you're looking for. So, and that really is a fundamental principle of this. So you define your goals at the beginning in terms of the briefing, and then that's obviously integrated into the design through stages, RIBA stages 2 and 3, and then going into more detail in terms of 3 and 4, and hand over to the contractor at 5. And when we come to 5, this is important in terms of our soft landings or our plan for use, which is coming out next week, and really handing over that in terms of how the building will be used and operated, and really setting up reality check and workshops throughout the design process. And part of that is this key part of the handover at the end of the design process. And that's where really our plan use comes in. So it's number 6 is the handover, where we actually work with the client and really trying to get architects to really engage in how the building will be used, and really hand over that building. It's like a baton, passing the baton over in a relay race, and thinking about the use of the building as well. And actually, as part of the RIBA, we're encouraging everybody to do a light touch POE at the end of defects period. And really that is now the benchmark for the new RIBA award criteria. We've set it back a year, so that we're really looking for finished buildings in operation. Our 2030 challenge, this graphic really sums it up. If we don't do anything, then it is we're on a future of +4 degrees temperature increase. If we try and do, obviously, most of the countries of the world have signed up, and hopefully we'll reinforce this in November this year in Glasgow, in terms of the 2050 as our backstop in terms of trying to hit net zero. But really at the RIBA, we've set our goal in terms of 2030, and this decade of action is absolutely critical. And what we're saying is that no new unsustainable buildings can really be built beyond 2030 if we're to achieve the 2050. And in the UK and other countries, that gives us 20 years to deal with the elephant in the room, which actually is our existing buildings which are poorly performing. We've got 27 million homes in the UK, 45 million buildings in total which need retrofitted during that 30-year period. So we set targets in terms of 4 of our sustainable outcomes. And we see here, I'm not going to read all this. I'm sure this will be all online. You can download the 2030 challenge for free. But effectively, it's looking at energy use. And what we're saying is, use your own current benchmarks. You can use local benchmark. It doesn't have to be the UK one. This is just for interest. But really, we're asking for a 25% reduction last year, 50% reduction on local benchmarks by 2025, and a 75% reduction by 2030. Now, the 75 is important because what we're saying is trying to achieve net zero on site is actually quite difficult with some building types. So therefore, if we relax it a little bit, then you're allowed to offset 25%. But we're really trying to sort of push that boundary to try and do as much on site as possible. Embodied carbon, we can see there, this is domestically, that's again a good 70% reduction there in terms of embodied carbon. And again, the figures are kind of developing as we're speaking there. And potable water use, again, it's a 40% reduction. But that 40%, even in the UK, that will require rainwater as well. Now, the unintended consequences behind all that, the rush to kind of save energy, we've got to be mindful of actually still creating good health and well-being within our buildings. So hence that we've got some backstop targets there for health in buildings. So that's domestic. So 35 kilowatt hours is our target in terms of operational energy. And non-domestic, you can see it's slightly different targets, but it's 55 kilowatt hours per square meter, which actually is linked to the science-based targets as well in terms of Paris proof. So there we go. That's the kind of the targets. And really just to say that all this has actually been developed with UK GBC and also the World Green Building Council. And we're really trying to get behind this, trying to kind of speak with one voice in terms of what do we mean by whole life net zero, and also how do we do it. So we can see here it's the combination of operational carbon reduction plus embodied carbon. And when you add the two together, that's where you get your whole life carbon. And that's really what we're trying to do. So can we do it as a community? Well, there's a couple of projects in the UK which have done it, which I'm just going to share. And then there's a couple from HOK in the region as well, which I'll touch on, see how well we're doing. So this is a small house in England, and it's a Passive House Plus. So what it means is Passive House is actually net zero, near enough. And we can see there, this is a net positive building because it's actually got PVs integrated to the roof. So this is kind of really what we can do in smaller projects. And you can see here there, the surplus energy is effectively powering the owner's electric car. So we can do it at this scale, and we need to do this repeatedly, and we need to do it at larger scales. So if we go into this one, this was the Sterling Prize winner back in 2019. And when we looked at the stats of the building, it actually sort of hit our 2030 challenge, which was quite amazing. So we can see there enormously sort of low 90% reduction in operational energy use. And you can see there 236 kilograms of CO2 for embodied carbon. So it almost hits our 2030 challenge on both measures. So, and it creates a fantastic place for residents. It's about 150 units, and actually lifts the community out of fuel poverty as well. So this is has not a profound effect on obviously what we can do in terms of saving CO2, but actually from a social point of view and all the other sustainable development goals, it hits every button. So really what we're saying in the UK is we can do it at this scale. So there's no excuse really for the rest of our profession. We've all got to try and achieve this in our future schemes. Going up to more complex buildings, this is a university building, again in Norwich in England. This is a Passive House, again, larger building. And we can see there it hits 70 kilowatt hours per square meter. Now, this is actually operational energy, so it's include regulated and unregulated. And this is the actual figures. So this has actually been monitored for many years. And we can see there it's about 68, nearly 70% reduction, but that is excluding renewables. This doesn't include heat pumps, nor actually the PVs. If you added that on, then it would easily beat the our 2030 challenge. And the walls are made of straw as well, so straw cladding. So we believe this also hits our 2030 challenge from embodied carbon as well. So again, at that scale, we think we can do it as well. And the final sort of UK project I was going to touch on, this is the Everyman Theatre. This is won the Sterling Prize about 10, 15 years ago. Now, this is important. So this is a building that won because it's a fantastic, beautiful building. It's inclusive. Its social value is beyond measure in terms of its Liverpool and also a national level as well. But actually, it's a naturally ventilated theatre, and actually reused brickwork from the previous building on site that was derelict. And the two together really actually created there, and when we looked at the analysis there, it actually achieved nearly our 2030 target on both measures. And so the main thing which we're trying to do in the RIBA is actually shift what good looks like for the Sterling Prize. And then we're very hopeful that in the future, really it's only going to be net zero carbon buildings that actually will win the Sterling Prize first off. But really it debunks this myth as saying, well, actually it's maybe worthy, but it isn't aesthetically pleasing. But this is where we're trying to do two things. It looks beautiful and actually saves the planet at the same time. So that's our ambition for the future. So just a couple of projects from HOK in the region. So we got our office in Dubai, and obviously got lots of examples in Dubai and elsewhere. But this is a couple in Saudi Arabia. So this is Capsart, just outside Riyadh, finished in 2014. And this was built as part of the support community for the new university in this area. And it's about 200 units, and it's about 2,000 residents. So it's all part of that community. And at the same time, my colleagues who were developing this, they actually created a new sustainable design code, very much kind of using the sustainable outcomes as before we obviously created the RIBA sustainable outcomes. And we can see there sort of looking at the site, looking at urban planning and transport, looking at the public realm, also district cooling, and looking at building energy and water. And the authorities in the region found this very interesting, and I think this has actually been the basis of, I think, sustainable development throughout Saudi Arabia now. So the site, you can see here the 2,000 units. Now, one of the key moves is to actually sort of create an increased density. So actually pushing the buildings closer together, and you can see the grain there is very much vernacular grain, and it's actually creating very much self-shading elements in terms of courtyard and streets and lanes. and then really creating that kind of more social thing as well, where actually the cars were pushed to the edge and to the back service lanes, which then allowed a bit more permeability and beautiful kind of sort of areas for walking and cycling, very much part of that space. So that's kind of the whole aim. And you can see the mixed use was very much kind of identified in certain zones of the site. And this is a view of the central kind of sort of town square with the mosque in the center. Lovely gardens, obviously just growing up just now. And then the architecture very much kind of its place, really sort of deep reveals. We can see shading as well in terms of the color palette. And then the predicted end use there, which is again based on ASHRAE 90.1, it showed a 20 to 50% reduction, which actually, coming back to our targets in the UK, is actually extremely good. That's 30 to 75 kilowatt hours is actually very good, especially the 30, and that hits our again aligns with our 2030 challenge as well. So great work. Now the thing is, obviously we need to go back and understand how our buildings are actually sort of working in reality, and that's something that we need to touch on, not only in UK but obviously around the world. We need to get back into to really share understanding of reading our meters and what buildings actually use. The next project was the KAUST. This is completed 2009, sorry, and this at the time, I think this is, I don't know if it still is, but it's the world's largest LEED Platinum building at around about 300,000 square meters. Now we can see here that the buildings facing the sea there, and they were sort of, again, similar idea. It was actually pushed closer together to create this kind of sheltered, shaded areas, which were actually naturally ventilated. And then the whole development was orientated towards that kind of prevailing wind off the sea, the Red Sea, trying to get that cool breezes across and permeability through the actual master plan itself. Lots of features on this building. Really, I suppose the main things that come across is this, again, building on this basis of a very kind of good passive design and all the kind of thermal mass within the building, but really topped off by amazing level. I mean, nearly 17,000 square meters of PVs producing 4 megawatts. We see solar water panels and lots of other energy efficient methods, but it also hits some of our other targets in terms of water use, in terms of reduced by, you say they're around about 40%. The materials, again, where they were coming from, trying to get as local as possible and recycled, and obviously all the wood was FSC approved, and then trying to reduce waste. We almost got to that 80% in terms of waste. So again, that's fantastic stats of a building of this scale. The key move here really is, we can see this in this section, the roof, very much kind of that idea of creating this kind of sort of shading, and it's almost a principle of layering. Especially where you're trying to sort of not do everything in one go, but you allow sort of interstitial zones which actually sort of start to cool the building sort of slowly. So we got the big shield roof with the PVs creating a big parasol. And then we've got the wind funnels through the actual the lanes between the buildings, and really creating a cooled area with some evaporative cooling from water. And we've got the solar chimneys towards the end there, so really sort of helping that stack-induced ventilation through the spaces. And then this is a couple of views. So inside, again, a lovely kind of cooled, diffuse daylight, and you can see it feels lovely in terms of that daylight quality as well, helping to reduce energy use. And then with the outside spaces, we can see are shaded, very much kind of using the Arabic screens there, lovely sort of corner quality of space and materiality. And overall, this is achieved around about 30% better than ASHRAE 90.1 at the time. But at the same time, obviously, the authorities actually sort of, acquired kind of energy, the rest of the energy from renewable energy sources to create a net zero development. And we can see the roof of the PV roof there, which is absolutely fantastic. So just to leave you a couple of things here. So just as kind of some watchwords, really, the first one is I think as architects, we've got to assist our clients in terms of carrying out post-occupancy evaluation. And some of the studies in the UK really shows that you can reduce energy use by about 20% if you do a careful POE. And really, so clients, if you say to your architects and engineers to get them in to actually work with you. And next one is really target that net zero whole life carbon. It's a whole life, the combination of operational and embodied really is the future, and that's how we achieve our true net zero. Prioritize deep retrofit if you've got existing buildings. Think about how we can reuse buildings creatively. And then in terms of non-domestic, we're calling it DECI in the UK, but that's really sort of that basically that 75% reduction in energy use. For domestic level, we use passive house level in sort of UK and also Europe. But again, that's the whole thing of really putting the emphasis on the envelope of the building to do most of the work. UK, we're targeting 40% reduction in water use, but some of our other buildings around the world and even in the States as well is targeted 100% reduction in water use, especially 100% irrigation would be from rainwater. We target well building standard or equivalent for health and well-being, and then the key thing there is obviously increasing biodiversity and green cover significantly. Thank you very much.
Much appreciated. I think you covered very many different items there in a very short period of time. But I think one or two things which cropped up throughout was it's important for us now to be at the stage where we actually do analyse and look at any performance gaps that we may be finding now in our built buildings, as opposed to the I suppose the simulated or modelled criteria that we use during the design phase, and that it's very important now.
Yeah, I think that's a really important point that I think maybe get some reaction from the audience. It's very difficult, even in UK and in Europe. There's not sort of a natural ability to share energy data of buildings. I think people are very cautious of that. But really, in terms of actually, there's a growing movement in terms of sharing data, and that's actually where all the lessons learned can come out. So that's very much part of our agenda, and hopefully that if we continue that around the world, we can all learn how to deliver net zero.
It will be key, and it'll be interesting to see our clients' responses to this. Thank you. Thank you very much. And now, last but not least today, we're delighted to welcome members of Arup's team here in the Middle East to present to us Arup's road to net zero. Joining us today is Gaif TV, Samima Saqib, and Mercedes Jogello. Gaif is a senior consultant at Arup, an associate member of the Royal Town Planning Institute in the UK, a member of the Association of Energy Engineers in the United States, and a lead accredited professional. Mercedes is an associate at Arup, an RIBA chartered architect, and is the Honourable Treasurer of the RIBA Gulf chapter. Samima is a mechanical engineer at Arup. She is a results-driven designer with an avid interest in combining new HVAC technologies with rising renewable energy technologies. Team Arup are here today to highlight the 3 steps to take now, covering the route to be taken in order to achieve net zero targets, and will highlight the importance of this to be adopted across the entire construction industry. So thank you very much, Team Arup.
Thank you. Thanks, Sandra. And it's really a pleasure for us to be with you here. And thanks everybody for joining us today and taking the time. We will talk you through some of the steps that can help us all get to net zero buildings. And I think the speakers before us, Mina and Gary, have done a great job in introducing the sort of the strategic side of things and where different elements tie together into this agenda. Today, I mean, what we will do is to focus on some very tangible, specific strategy examples for buildings specifically. And so if we start with a quick, the next slide, we will, sorry, if Mercedes, we can get to the next slide, please. Okay, I think we're done with the introductions, so you know a little bit about us now. And so really the first bit we thought we'd talk quickly about is some definitions. And I think Gary touched on this during your talk. And that's really about understanding the total, carbon zero versus energy zero and the what is what, basically. And so just very simply put, there is embodied carbon, and then there is operational carbon, and combined together, that's what we get, where we get to the total carbon. So when we say it's a zero carbon building, what we mean really is we're tackling both the embodied carbon and then the operational carbon. Zero energy, however, could be, well, is essentially focusing only on the operational side of the building, and essentially the operational carbon footprint of the building. Whereas embodied carbon is talking about the construction materials, processes used to build the building. And so combined is basically what we need to do. We need to combine these two when we are designing buildings to get to zero carbon buildings. Next slide is a bit of a simplified diagram that helps us also understand the different set of strategies that can be applied, and the approach of the hierarchy to applying them for tackling both the embodied carbon and the operational carbon. So if we look first at the lighter green, and that's the embodied carbon bit, we can look at how we would always try and start with building nothing, because essentially if you don't build, that's how you kind of reduce your embodied carbon to zero. Of course, that's not always feasible. We've got to build every now and then, depending on what is it that we're building. So even when we have to build, then we move on to the next bit in the hierarchy, and that is building less. And then building obviously clever, and that's where we can think about using, building designs that can be used for multiple purposes and space planned in a way that can make better use of same spaces, and therefore build less space in the first place. And again, building efficiently and minimizing waste go hand in hand to ultimately reduce significantly the embodied carbon of buildings. And then when we're left with the very little carbon that's got to be there, because we must be using some material to build new buildings, then we can target offsetting that offsite through some certified carbon programs, which are widely available now. So that's how sort of the approach and the hierarchy of approaching reducing embodied carbon can be on the buildings. On the operational side, and that's the darker shade of green in this diagram, similarly, the really key strategies to target, and again in this order, first we start with passive design measures, and those are the ones that help us reduce the energy of the building without even using any energy, and that's things like designing a very well designed envelope, and Mercedes will talk us about some more detailed strategies related to passive design. And then looking at active systems and how these can be designed in an efficient way so that they can consume less energy. And then during operations, you can use those, controllers, smart and digital tools that can help us operate buildings at a lower energy consumption. And then to offset whatever is left of our energy, we target or try and use on-site renewable energy as much as possible. And that's essentially how we can get to potentially zero energy building. Grid decarbonization is another layer that goes beyond the building and looks at the city scale or master development scale, which is also something when we are talking about a wider site, we would look at. So I'll pass it on to Mercedes now to talk us in more details, specifically around passive design strategies in buildings. Over to you, Mercedes.
Hi, hello everyone. Thank you, Keith. So good passive designs deliver buildings that emit less carbon in operation, but also often are more comfortable and achieve higher levels of occupant satisfaction. We know the fundamental decision made at the earliest stages of the design phase, including massing, floor-to-height ceiling, and facade design, has significant carbon impact through a building full cycle. We're going to look at some of those passive measures. To start, a well-designed building should respond to the external influencing factors, such as orientations, climate, and occupancy. An important first step is to consider passive design measures to prevent excessive solar gains and heat entry, and that's particularly very important in the summer in the Middle East. As such, we should always start questioning the orientation and the form of a given project, and that will be In many cases, it will then detect us how we can then apply passive measures on it. For example, building that comes with a very deep plan can be very difficult to consider natural lighting. On those buildings that has a high exposure to the southeast, to southwest, or a very large skylights will be leading to very high solar gains and will be obviously sun overheating. When we focus on the building itself, it is quite well known that if we have a poor building envelope, it will lead to a high energy use. So when we're trying to reduce that energy, then we need a high performance building. But the key question is how we get to do that. So it's important to understand what's the purpose of an envelope. And this might sounds very basic, but it's very important to have those two concepts in mind. The first reason is a shelter. And that's one of the main reasons why we have buildings. So our envelopes act as a barrier from the house environment. It could be the heat, the wind, the rain, and it creates an indoor environment that gives us comfort to live in. But not everything is bad from the outside. We also need that natural light. We need the fresh air, and many times we also want the view and an interaction with the outside. So finding that optimum balance is key for a successful facade, and it's key to achieve that route. And that's what you're going to hear me quite a few times to talk about today, about finding the balance. It is well known that energy transfers through three main paths: conduction through a body, convection through the air, and radiation through waves. So if we apply these three concepts into a building envelope, we have the conduction, it happens through our solid walls, and in a combined way, it's also happening through our insulating glass units or also through our air cavities within the walls. Convection also occurs when one end leaks through the joints. And then obviously we have radiation, which occurs mainly from the sun when hitting a surface. Some of that radiation gets reflected back, some of them transfer in, and some others absorb and then radiated later. The balance between daylighting, solar gains, and artificial lighting should be considered prior to developing the facade treatment. Solar shading can be a very positive way of reducing the aims. If we have a very poorly orientated building with glazing ratios of over 60 or 70%, it might end up with, it might require very or excessive external shading to control the heat gains. On the other hand, if we have glazing ratios less than 20% or even less, it might lead that we need to increase the artificial lighting. When we look at the thermal transmittance, and also known as U values, that quantifies the amount of heat that transfers through a particular building fabric. We know that the lower the U value is, the less heat that comes in. So a good facade performance will reduce the energy by improving those U values across both the solid and the vision areas. In addition, we need to minimize the thermal bridges because this also will help us to ensure the overall performance. Low levels of air leakage can reduce the heat gain from the external environment. This is particularly important at the interfaces between facade system and open mechanisms, and is very frequent linked to good quality of workmanship on site. Against balancing is what we need to consider when we want to identify a sustainable and a low operation carbon solutions. At Arup, we advocate and undertaking modeling studies to find an optimum balance. And the aim is to visualize the results and identify the optimal contribution of inputs, such as cooling loading or the lighting target, and that help us to achieve the required design output, which could be the glazing areas or the particular performance. This gets enhanced with parameter approaches during project development, ensure the initial design decisions are well informed. The image on this page shows a parametric model approach when considering window or glazing area, which has implication on the lighting, cooling, and sometimes heating requirements. A step further, will be to assess the impact on opening windows should a mixed-mode approach ventilation strategy be explored for a portion of the year or for certain type of buildings. Summarizing, the building envelope design could help significantly in reduction when we follow these steps. We start with the energy model of the base building. The step 1 will be to adjust the orientation and minimize the glazing on orientation with high solar exposures. Steps 2 will be optimize the amount of solar energy through the glass by adding shading or establishing the appropriate coating selectivity of the coating. Step 3 will be to improve the thermal performance of the facade, and step 4 will be to set low air permeability values that we know they are realistic and that can be then achieved on site. All these steps are enhanced by our in-house developed tools, such as the Arup Solar, that allow us to adjust building design aspects simultaneously. The aim of these tools is to significantly reduce the architectural and facade workflow process, allowing us to assess multiple design options in real time. And I'm going to pass to my colleague Samima, who will take us through the demand management and active systems.
Thank you, Mercedes. Let's look at the main culprits of energy consumption in Gulf region. According to recent research, 60 to 70% of energy demand currently stems from building HVAC, lighting, small power, and miscellaneous loads. To minimize this energy, we need to implement active and operational measures. Next slide, please. Active measures or energy efficient systems provide the required internal environment and services with minimum energy use in a cost-effective and environmentally sensitive manner. Operational measures or demand management strategies shift energy demands away from peak periods when sustained supply emissions are at their highest to other sources such as renewables or energy storage. Next slide, please. Energy efficiency is generally the most cost-effective strategy with the highest return on investment. Some of the energy efficiency measures that can be implemented to net zero energy plus carbon buildings in terms of advanced HVAC systems are air to water side heat exchangers, EC motors for AHUs and FCUs, intelligent valves, sometimes known as energy valves, environmental sensors, and maintaining filter efficiencies. Employing LED light for energy efficient artificial lighting integrated with multi-sensors to detect daylight and occupancy. Plug load and miscellaneous load can be mitigated by selecting equipments with lower power demands, such as those with energy star rating, or by employing smart controls. Next slide, please. Demand management measures reduce building demand without having a dramatic impact on operation or comfort. It is driven by energy efficiency measures and building automation. Building automation is a perfect tool for implementing small changes that can trim energy use enough to meet demand. One way of implementing building automation is via IoT, Internet of Things. Next slide, please. Internet of Things transforms physical objects into smart devices to collect, communicate, monitor, and interpret information from their surroundings in real time. It can be linked to all of the energy-consuming equipment in a building. For example, environmental sensors linked to building HVAC can provide detailed data on IAQ parameters such as humidity, temperature, VOC, particulate matters, and carbon dioxide. Smart lighting sensors linked to building lighting system can detect daylight and occupancy. Smart meters can provide real-time data on energy consumption, allowing a better understanding on how occupants use their energy in a building. According to a recent research, IoT-based smart controls are predicted to reduce global building energy consumption by 10%. Savings can be between 15 to 50%, and global emissions can be reduced by 15% in the next decade. Building automation management systems have been around for some time, but their main function is to monitor and flag issues. Next slide, please. More can be achieved if there is a central analytical platform such as Neuron, which is an innovative console which embodies 5G, IoT, big data, cloud computing, and AI technology for smart buildings. It has been developed by Arup and can be fully integrated with the existing DMS as well as with various data sources generated from IoT sensors. Through AI and big data technology, real-time building data can be analyzed, which can provide the insight on how the building performs. And based on this information, the BMS can adjust itself automatically to achieve energy saving and a better building performance. Next slide, please. The final aspect of net zero energy plus carbon building design is renewable technologies. Some of the renewable technologies applicable to GCC countries are solar energy, most commonly used as solar photovoltaics or solar thermal systems in buildings. Wind energy, building application is not common in GCC due to noise generation, its visual impact, and relatively low wind speeds at ground level. But the wind speeds, since they are more stable at high levels, it can be an important factor to consider when deciding its application. Geothermal energy is relatively a new concept for GCC region and is not very commonly used due to the fact that the ground temperature in this region are quite low. Of the 6 GCC countries, Saudi Arabia has the highest potential for geothermal energy. Biomass from urban waste, also known as waste to energy, is one form that can be implemented by any country, irrespective of geographical or climatic condition. The following is an extract taken from IRENA publication that shows the various forms of renewable technologies currently implemented in the GCC countries. Though all of the above mentioned are important for net zero energy buildings, there's one aspect that is not considered in design, and that is because it's difficult to integrate, and that is user behavior. Next slide, please. Since building users in Gulf countries, sorry?
Is it possible, Samina, we could wrap up quite quickly and then we can get
Yeah, it's almost there.
So sorry, thank you very much.
Since building users in Gulf countries spend 90% or sometimes even more of their time inside the building, reducing energy consumption is a challenge. It can be cultivated through personal management, education, training, incentive-driven policies, or by providing a thermally comfortable outdoor space within the boundary of the building. It is difficult, but not impossible. Some of the concepts that can be part of future research are exhaust air from dedicated outdoor air systems can be used for cooling, employing vernacular design elements, using comfort cooling as means of transfer air, and finally by employing chilled radiant wall technology. I'll pass on to Hayat, who will talk about the approach to net zero energy plus carbon building design.
Thank you, Samima. I mean, just in the interest of time, I mean, this is just to reiterate the message that this is a journey that begins at the outset of the project when there is a brief for the project and then carries throughout all different stages. And at the different stages, there are different approaches that will need to be applied to reduce both embodied carbon and operational energy to get us all to where we need to be, which is zero or even net carbon. The next slide is just to also iterate a very important message, which has to do with the design approach. It's got to be an integrated design process where different teams and different disciplines and stakeholders work together to achieve that holistic design along the journey of the development and then operations of the buildings. So we need to move away from the traditional linear design process and get into a more integrated design approach. Thank you all for the opportunity. If you'd like to get some more details, there are some free research pieces on our page, and you can have access to them if you'd like to. And of course, we're more than happy to answer any questions today. Thank you very much.
Thank you very much, Gaif, to you and the team. Sorry that we're running over time slightly and had to push you towards the end there. It was also very, very interesting and so very key. You did mention that during the presentation. The key element is to go back to basics each and every time. And certainly when it comes to sustainable design, that's really where we must start with. So thank you very much to you and the team today. Now
You're welcome.
Thank you all. We'd like to now open the floor to the audience to ask some questions and engage take their opportunity to engage with such industry experts that we have on board today. So if you don't mind, we'll roll quite one or two of the themes that we're getting into one question each from myself and Andy, and then perhaps we'll have one or two other questions if we still have time at the end. A common theme that's coming through is open to anyone on the panel who cares to answer. These targets, the goals and the timelines that we're being asked to work to, how are they being policed? What is the what will happen if the targets are not met in the timescales that have been given? I mean, we've had so many targets over the last decade or so for other elements, not just net zero, and it seems that as soon as we get to the point where we're close to the targeted end date, like 2025, 2030, etc., then new sets of targets come out with new requirements. So anyone on the panel, what do you think we stand with this? What do you think? What do you think we can do to improve the past history that we've seen on all the targets that have been set so far?
So, Sandra, if I just kick off, just to give you a little bit of glimpse of what we're doing behind the scenes in the UK and touching around the world as well, is there's a lot of work going on. Is speaking with one voice. So we're trying to, RIBA, all the professional organisations in the UK are meeting regularly. Plus actually grassroots organisations like LETI, ACAN, Architects Declare. Now, what we're trying to do is actually trying to stop that. We're trying to get a roadmap for the next 30 years. It isn't just for the next decade, it's for the next 30 years. And then we all agree in terms of what do we need to do when, and then timelines there and the targets are there. So that's going on behind the scenes. So it really is encouraging everybody in different countries watching the principle as well. And really, I mean, the goal is net zero. Okay, so it's how fast you can get there is more the issue. And we've just done a straight line for the next 10 years for new buildings. But then it comes into how do we enforce that? So at the moment, really, this is all about sort of doing the right thing. And a lot of companies and actually the government as well in the UK, we're all behind this. We all want to do it. And really there's a goal to try and be the best and all the rest of it. So that's what we're trying to do. At the same time, we're lobbying government to lock in this to this trajectory into the UK carbon budget. So there's a lot of work going on in the background and hopefully that will be announced at COP26 this year. So we must do this. But you're absolutely right. The main thing here is we can only go so far. It's our clients have got to really buy into this, but we need governments as well.
It's collaboration at all levels. Thank you very much, Gary. I think we have a question from one of the audience. Andy will be.
Yep. Hi there.
Can I ask you to?
Yeah, is anybody in the panel that wants to ask? It's regarding embodied carbon and embodied energy. Are there any accreditation programs that are robust and are emerging as a best practice to kind of account and deal with this? It's maybe the less obvious side than the energy in use, but so what's appearing to be the best accreditation program? Anybody want to answer?
I can just briefly talk about this from the Middle East perspective. I guess at the minute, there isn't a lot of certification systems that look at carbon, embodied carbon. There's definitely credits in some of the certification systems, such as Istidama, LEED, and others that encourage projects, but these are optional. So currently, it's really up to the client to decide whether they want to target the life cycle carbon accounting sort of process and then use the internationally recognized methodologies to apply them on a project. So yeah, I guess there's quite a lot of work to be done, I think, on this front. Although there are some good progress on it, because there is definitely a lot of looking at using local materials or materials with low carbon footprint. And I think that is something that's happening. We're not yet at a place where we actually do this on a regular basis and look at the whole life cycle of products. just yet.
And if we can add, it's also quite important about data and factories releasing data, because we might find very good sets in certain countries, but then it won't be the same. A product that is built somewhere in a factory in Europe won't be the same embodied carbon that if you take that product and bring it to the Middle East, because the transport is also count on it. So it's about availability of the data and the governments or the policies requesting the manufacturer to release that data will help a lot when calculating embodied carbon.
So, Andy, if I could just add to that, so there's some good news that the environmental product declarations are sort of rapidly exploding in Europe. So actually, there's researchers linking all this around the world. So I think there's some data. There's about 5,000 products so far, going up to hopefully more. And then when you then factor that, then absolutely right, as Mercedes was saying, is you've got to then look at the travel distance of where it's coming from. But I'll just say that there's an online tool, OneClick, that our HUK Sustainable team uses, and it's you can actually, if you're a student, you can actually free to download it as well. And I think by Leave Arup have got a fantastic embodied tool as well. So I'm not going to plug your tool, but yeah, I think it's really good.
Yeah, we have our carbon tool, yeah. But it's about the data that is behind the tool, that rather than the software, is what is really key.
Yeah, so RICS, the Chartered Surveyors in the UK, the latest news is that they are maybe going to pick up the ICE tool. So it's a nice database that has a track of actually all the main materials around the world. So I believe that that's now going to be part of a collaborative attempt to create this kind of global database. So it's still early days, but we're all on the same page in terms of we need to sort of push the same amount of effort we've done in operation onto embodied carbon.
Thank you very much.
If there's no more to add, I'll ask another question. Any other answers to that one from the panel? No, okay. I'm going to move on to another question, kind of combining several that have come in. I have to say, we've not that many questions from the audience this time. We'll only get a lot more. There's still a chance to put some in. But there's some about policy and enforcement. So I'd like to know from all the panel and their experience here, and even in different locations, what do you think would be the most effective policy that countries can have now? And what's the kind of fair and effective way of enforcing it as well?
I think if I may come in on that one, Andy, this is just in general. I think the key policy will be to demand the in-use stage measurement of buildings' performance. Gary, Mercedes, the Arab team have also touched upon this too. The understanding of the actual performance of the built environments that we're designing is really important, and that's a gap that's currently not fully filled or appropriately filled to be able to deliver on the ambitious targets that we've talked about today. So it's really important, I think, to encourage post-occupancy evaluation and use data monitoring. Actually, I would say even go beyond encourage and enforce that, because that's the only way we can really understand how far of a gap there is between what we're designing to what's actually being built. So that would be my one ask for the policymakers to embed in the policies all around the world.
Mina.
Yeah, I mean, I'd add my voice to Mina's point. I think that's absolutely important. We do a lot of work on the design side of things, lots of analyses and simulations and optimization and all the rest of it. But what gets built sometimes is different for all sorts of reasons. So I think we've got to get some regulation put in place, and those need to be updated regularly and also informed by real-time data and information from existing building stock. I mean, some of the good news, I would say, at least from the Middle East perspective, we're seeing a lot of updates and changes in building design codes. And I mean, one of the most recent ones is the Dubai Building Code. There's a unified Dubai Building Code today that applies. It's really, I think it was issued last month, and we were involved in its update, and it's one of those really, I think, tools that can help basically the sector evolve and develop and start aiming for higher targets. And I think something similar across different cities need to take place to raise the bar essentially and get the industry to aim higher, especially that the economy is of scale will only get to where it needs to be with a bit of push, I think, from policy and regulation level.
If I may, Sandra, just building on that as well, it's just a small thing that we've been lobbying hard in the UK government for many years behind the scenes. It seems like the latest future homes and future building codes coming out just now, and it looks like 2025 is the time when the government look like they're going to move to operational targets and then in-use verification. But what we've done is, as an industry, is actually really lobby hard in terms of saying, if you're to meet your carbon commitments as a country, you can't hide behind it. You've got to then deliver that. And then there's lots of other benefits that we can do. So we've actually been, there's lots of reasons why to do it, not just about saving carbon. So so hopefully that can help others in terms of different countries how to approach their governments.
Thank you, Gary. Anyone else? Thank you very much. Very, very interesting answers there. And all across the board, it's very clear that we do need better regulation, better support from our governments, from our institutes, from our organizations, in order to meet any targets whatsoever. We must all work from the same hymn sheet, basically. So we do know what we are meant to be delivering. I have one small, quick question for an answer. It will be hopefully a very quick question. It's very focused on, can anyone answer the question that's come in on what are the lowest carbon options for active cooling? And certainly here in the Middle East and the Gulf, it's a very key question for us, this one.
Yeah, I was hoping that somebody from Arabs would be able to tell.
Well, it depends on the building and the type, the scale, because there isn't, one of the things we come across, and maybe Samima can add a bit more on this, but in principle, it really depends on the building. We have to think about, is it a high-rise tower? Is it a small townhouse? Is it how it's been designed? And again, I think one of the key points about the diagram we had in the presentation, the hierarchy of approaching the design, you've got to start with passive, because your cooling load is really a response to how good or not so good your building envelope is, how big the windows are, how well performing are they, and so on and so forth. So to get to the active cooling bit, you've got first to really do a great job on the passive side of things, and then you get to the cooling. And then, like I said, there are different answers on cooling, depending on the scale of the building, the use of the building, and so on and so forth, and how energy is sourced for that building. Maybe Samima would like to add anything. Sorry, we can't hear you, Samima.
Anyone? No?
Sorry, rookie mistake. I agree with you. There is no right or wrong answer on what is the most preferred active cooling method. Obviously, I'm talking about GCC perspective because I have more experience over here. And it all depends on how you're using the building, what the building purpose is, and how the building has been designed from an envelope perspective. That's the basic steps. And then you go into deciding what type of systems you want to implement. There's so much talk going on solar assisted cooling, geothermal cooling, but it all depends on where the building is located and how you can use that kind of energy or technology in the building. I don't think there is any innovation left in the market to come up, but it's only improvements. And like I said earlier, building automation is the most important aspect nowadays. How can your building, how would your building respond to the changing needs of the occupants or the changing environment? That's the most important today, rather than looking at the system specifically.
Thank you very much, Samina. Well, lesson learned. There's no such thing as a short answer to a short question. Thank you very much, all.
Hi there. I think we have Julia, a student in Liverpool, in the UK, is going to come and ask her question. I've just brought her up to the panel. Hi, Julia. If you're there, you can put on your mic and you can put your question to everybody here.
Oh, hello. Yeah, I'm just wondering what you think the improvements to the built environment that come with the sustainable approach. I think for me, it's about change in education. And I just wonder how you see that coming from the top down. I'm a student, so that's why I'm interested. But yeah.
When you refer to education, what do you mean?
Well, I think there's one of the things about sustainability is that it's a great idea, but the people applying it at the lower level, actual builders, are trained in unsustainable ways of building. And so I wonder how you see education maybe playing a role in sustainability, if you see what I mean.
Yeah, I would agree that it needs to be across all the parties involved in the construction, so not only at that designers level. Thing has been touched before. Awareness is very important to this sort of series like the one we're doing today. I'm talking about the topic rise awareness, but it needs to go beyond that. And Keith, my colleague, mentioned when we have been improving the code locally, we had to be in mind and working with authorities that the contractors, the suppliers, the manufacturer need to be able to cope with this. You can't do a massive step, and then the industry fall behind because they're unable to deliver to that. So you need to gradually pushing the people to, and that's why the targets might be in 10 years, 20 years, because you need the industry to be able to walk in that direction, but it needs to be a step by step. We cannot do a big jump, unfortunately.
And I think if I may add on that, Julia, thank you for your question. I think what if I'm understanding correctly, what you're actually asking whether there needs to be actually not whether, but that there's an importance of understanding sustainability holistically rather than just talking about energy and carbon, which is the whole industry has been focusing on, because especially for embodied carbon, among many others, we're so behind, and carbon is one aspect that we need to immediately get right. However, it's really important to understand sustainability holistically so that we don't create unintended consequences, which many of us talk about in the industry, where we design very energy efficient or low or zero carbon built environments while we are unintendedly or unintentionally exacerbating health conditions that people may be experiencing indoors in those buildings that are super high efficient, but not necessarily contributing to the well-being of the people. And I think upskilling, I think you touched upon something really important, education and sort of upskilling and building capacity around multitude of topics besides energy and carbon is really crucial to be able to deliver these holistic solutions that I'm referring to here. And that comes with both the education that takes place at schools, as well as also a continuing education of the practitioners in industry. And if I can give an example, in the UK, we've been, within the RIBA especially, we've been actually trying to advance and progress this agenda quite significantly over the last few years, where we have created, and I think this will be soon a public knowledge, where the RIBA is actually launching a climate literacy mandatory knowledge and mandatory competency knowledge schedule, where there is a set of topics from health and well-being to biodiversity, ecology, to water, to energy and carbon, to connectivity and transport, that actually will demand all of the RIBA members to be upskilled or to have the appropriate levels of knowledge to holistically have the right climate literacy and apply that knowledge into their practice. So it's a long way to answer, but hopefully it gives the answer that you were looking for.
Yeah, definitely. Thank you so much. It's really encouraging, I think, to hear that there's really positive change going on. So thank you.
I can add something to this question as well. And it's quite interesting here. It may not have made the news outside UAE. Dubai announced its new urban plan for the next few decades, and it involves a lot more greenery. And we've seen Paris talking about this and lots of new developments where there's obviously benefits in planting trees and a carbon equation, but it's also as a place to live, as just kind of cleaning the air, somewhere nice to be, improving community, having a place to play. That is a kind of a good example of doing both. It's not just getting the carbon count down to stop climate change. We are, at the end of the day, trying to improve everyone's quality of life. So not just protect it. So I find it quite interesting now. That's quite a strongly emerging trend the last year or so. A lot more trees. I'm interested to see how Dubai plans to do it in a sustainable way. But there's definitely a movement towards a lot more greenery everywhere, as in the public space, public realm, between buildings, on buildings, everywhere.
And if I may add, I mean, I think we need to clarify that what we're talking about today contributes to sustainability, but it's not sustainability full stop. It's part of it, part of the agenda. I mean, if you look at the UN SDGs, for example, you can see it's a very broad set of goals and they cover everything. And there's one of them that talks about sustainable cities, just one of the 17. And today we covered bits of the built environment, but also the buildings within the built environment. So that's, again, it's a one part, very small, actually, relatively speaking, part of the jigsaw, whereas sustainable development as an agenda is way, much more than carbon and footprints and even trees and so on and so forth. It's way much more. There is this very big social dimension to it, big economic dimension, very important one. And of course, there is the environmental. So there are three different layers, if you like, through which we need to view our world. And the three layers need to be looked through every time we're making a decision, be it on the built environment, be it on the economy, be it on education, and so on and so forth. So sustainable development, it's way much more broader than carbon and zero building energy and so on and so forth. But I guess today's talk was focused on that bit.
Well, if I can jump in there, I don't think, we did talk about the wider holistic picture here. So the, again, so the UN Sustainable Development Goals, you can see it touches everything, but really it's absolutely key that we've got to get beyond just the triple bottom line kind of vague sort of levels. We've got to be absolutely clear about what the metrics and the key metrics are and how do we manage and measure it. Hence, that's the whole aim of the sustainable outcomes. There's about 30 metrics as part of that, which is actually the core, which we think are manageable and measurable by clients and contractors. And I noticed there's a few things there, questions about sort of contractors as well. We've got to lock in those outcomes with the client and government. We then write it right into our specification in our documents, and then therefore it can't be value engineered out. That's the absolute thing. So and it is this kind of wider thing, but the outcomes does touch on all that, the holistic sort of picture of it. And we need to sort of really educate as well. So we need to get sure that everybody's aware of what's that, including contractors as well.
Okay.
Thank you very much.
I've got a question I'll add.
Your question, Andy.
Yes. Interesting expansion of this topic, actually, just the big picture. Slightly different type of question for all the panel again. There's been the RIBA in the UK have been talking to the government about having a carbon tax. The UAE introduced its first tax a few years ago, and the other GCC countries a VAT. But perhaps it missed a trick in introducing a carbon tax and putting a price on what the amount of carbon you're either producing or embodying. What do you think of this as an approach to dealing with the road to net zero for the next 10 years?
Who are you asking? Anyone?
Anyone happy to answer.
So if I could answer, it might not be linked, but a few years ago, Neil Wansley, who used to be in is now in our Singapore office, he used to say when he was asked about the car and the private cars here, and how the people will stop using cars, and he was always saying is by putting tax on it, putting tax by parking, putting tax. So I'm asking the people, when the people touch the pockets, then the people will stop using, or will start thinking, do I need to really take my car there? Do I need to really pass this motorway, or do I need to? So with the carbon, but it could be similar. So when you start putting fines or payments, then people start thinking twice. Oh, do I need to redo this again, or should I buy this other product that it has less carbon, so I don't need to pay that tax? So it's always kind of a dramatical solutions, but it's, as I say, if it's at your pocket, most of the people will act.
So,
I'm not saying for that I'm encouraging, but that's realistic.
So Andy, I mean, it's a really interesting question, that, and Mercedes, this is why we put the net zero operation in the body right at the top of the 2030 challenge. Is the carbon is a proxy for lots of other things when you're making stuff and things like that. So I would say yes, it's really welcome. I think that UK government didn't do it this time, but we know it's still in the background. But that will adjust behaviours. You know, again, the cost of carbon, I think, is around about $40 per tonne, but that really is underpriced. It really should be, you know, the cost of that should be a lot higher. But really, it's picking up our separate thing in terms of the ethical side of things. So when you're balancing up sustainability, it's the ethical cost of things. So sometimes the carbon doesn't capture the whole ethical side of things. So you need to do a bit of both there, Andy. So, but I'm really pleased that some governments actually started that around the world, because that is actually a key driver for change.
And if I may also add, just as an example, I think it's really interesting question, and greatly appreciate the conversation here. And it's worth also identifying, not only sort of giving examples of how some governments may be introducing a tax, but also how that introduction of tax is actually significantly impacting the way that the processes are taking place before coming to that end point. An example is in New York, there is recently, over the last 2 years, a new law I think is being enforced now. It's called the Local Law 97, where it is actually demanding the built buildings to be measured from a carbon perspective, and then whatever, if they are not meeting the targets that are defined, then they will have to pay a penalty. And that actually, just introduction of that law is influencing the way that the buildings are even designed from day one. So I think that the change of the process is also the more interesting, I think, aspect of it, rather than just looking at how people will be penalized if they're not meeting the certain targets, which is the stick of the equation here. But I think I find the change of the process side of the equation much more interesting, I think.
And if I may add, I mean, definitely there's got to be a stick, I think, but there's always got to be some carrots. And also, when things are introduced, I think their impact needs to be looked at different groups and the community. So applying the tax on everybody, you know, those who own, I don't know, large portfolios, as well as the individuals who are just trying to build a home to live in. I think we've got to look at the social impact and the economic impact of those taxes. That's not to say we shouldn't be encouraging people to reduce the carbon footprint. It's just we need to help them do that as well, enable them, so to speak, and enable them at the different stages that before getting to the building itself, so the materials and so on and so forth. Because one of the things that tend to happen when taxes are introduced is that those prices basically are factored into the basically into the price of the manufacturing processes and then the products and so on and so forth. And what happens is just raises the price of the construction rather than reduces the carbon embodied in the production processes themselves. So I think there's got to be a kind of a balanced approach, not just focusing on taxes, but also helping, encouraging, enabling those who are emitting carbon to get to a point where they can reduce their carbon footprints through their processes and so on, rather than just pass on the price tag to those who are going to be paying for those products, which I think could be very unfair for big chunks of the community. So yeah, I think it's got to be a balanced approach, and it goes back to the wider sustainable development agenda that looks beyond just carbon and social welfare and the rest of it.
It's very important, yes, that it's not just punishment taxes that we look towards. You're right. People do need incentives, and positivity just tend to work, perhaps better than negativity, hopefully. Thank you very much. So thank you all. I don't know that we've got any much topics to cover yet from the question. I think everything's been touched on, and even our final question there from Claire was on positive tax. So thank you all for extending us your valuable time today. It's been a delight to have you all, and it's been a delight to have all the engagement from the audience. You've been great participants in the event today. So thank you all very much. We look forward to welcoming everybody at the same time on Wednesday. Our second webinar in the series will showcase regional projects in the Gulf, including, as Andy mentioned earlier, projects in Sharjah, in Doha, and the Mazda Abu Dhabi Future Energy Company's Eco Villa project in Abu Dhabi. So we do look forward to seeing you all again and to further discussing this very, very highly important topic, which has been seen from the length of time that you've all been able to give over to discussing the topics today. So thank you very, very much, and see you all Wednesday.
Thank you, Sandra, for hosting.
Thank you very much.
Thanks very much, Sandra, Andy.
Thank you,
And Andy.
everyone.
Thank you, everybody. And thank you, everybody attending. Feel free to get in touch to follow up and hopefully see you Wednesday as well. And any suggestions for future events, also happy to send us over an email. Thank you.